Welcome back, ladies and gentlemen. Here we are, continuing with our exploration of the mole. Now, last time we ended up talking about what the mole is and sort of roughly what it means, and we saw that it basically is just a way to use a single word to describe a full number, and that number is a very big number with lots of zeros behind it. Now, I kind of hinted at it last time that we're going to be converting between this because we don't have a device that can measure moles. Seriously, we don't have like a fancy gun that we could point at something and be like, that is exactly 2.6 moles. We can't do it. But what we do have are scales, and scales can take a measure of the mass of something. And as we saw, the moles and the mass are connected. The fact that they're connected allows us to convert from one to the other. So we've got one number, a mass, that we can measure. And we've got another number, a mole, that we can calculate. And the two of them work together. So if you guys take a look at page 7 in your book, we're going to take a look at the conversion approach. Right? It should look something like that. Oops, something like that. So it says here, 1 mole of carbon has a mass of 12.01, which means, of course, that 2 moles should be about 24.02, and 3 moles should be about 36.03. Very simple pattern. But not everything is going to be as simple as that. Sometimes we're going to get some weird ones. Now, when you're converting, you're pretty much always going to be following the same method. I'm going to show you, well, I already showed you, but I'm going to continue to show you a particular method for conversions. And this conversion method, this conversion matrix, this conversion formula, will pretty much work for everything that you need to do when it comes to converting. Heck, it'll even work for some of the hardest stuff in this unit, which normally is pretty challenging for people. So the way that this is going to work when you're converting is that our conversion formula is always the same. What I have goes on the left. What I want goes on the right. Then I put a pair of brackets and a division sign. What I want to lose goes on the bottom, and what I want to gain goes on the top, and it's all equal. This is what it's always going to look like, and then it just comes down to putting in the right numbers. And since that's all it is, I'm now going to show you by putting in some numbers. So it says here, we have an example. It says we have 2.5 moles of gold. Okay? So have 2.5 moles of gold. What do I want? Well, I'm going to want to convert it to mass, because it says, what is the mass? All right, so over here, I want grams of gold. Let's be a little consistent. Remember, gold is AU, because Latin, so aurum. I know, Latin comes up everywhere. Then we put brackets, and an equal sign with a division. Now, we have moles. We want grams, which means we want to lose moles. We want moles to leave, to get out of here, because we already have them. We want the other thing. And since the other thing is what we want, we put grams on the top. So far, this is all pretty straightforward. But the question now is, what numbers do I put in? Well, this ties into what we talked about last time. Grams per mole, the molar mass. And the molar mass is equal to its atomic mass on the periodic table, because that's how Avogadro set it up. So we look it up. Gold is number 79 right here underneath silver and copper. Wow, silver, copper, gold, all in the same family. I wonder if they behave similar in some way. Gold, it says, has 196.97. So 196.97 grams in 1 mole. That's because originally, remember, it was 196.97 grams per mole. Well, per means for every. Grams per mole is just a fancy way of saying grams for every 1 mole. It's just that rather than write that out, we put a little slash. And there's all these little symbols that we use to make things a lot easier to understand. The same thing is true, for example, say if I did kilometers per hour. Kilometers for every 1 hour, right? For example, if we were talking about a car and how fast it was going. Anyway, once we've put this number in, it now just comes down to converting it. We just have to actually do the math. So I grab my trusty calculator and I start punching in some numbers. It says here I have 2.5 and I multiply it by 196.97. Then I'm going to divide it by 1, so I'm not even going to bother doing it, equals 492.43. And that's it. That's the answer. It's all about the setup. If you set it up properly, it'll always fall into place. Setup is pretty important. Let's try another one. Okay, so we've got the first example. Our next example isn't so nice, right? 2.5, yeah, okay, maybe we could have done that in our head, especially if I'd chosen a smaller element than gold. But let's take a look at this next one. The next one says 1.2 times 10 to the negative 5? Oh my. And this is moles of carbon tetrachloride. Oh my. Carbon tetrachloride. Well, I tell you what it is in this case, but tetra is 4, and there's 4 chlorides with a carbon. It's a covalent compound. Other questions may not tell you what the formula is. You need to know what it is, which is why we spent all that time in the review section going over how to go from words to formulas. If you don't know how to do it, you're going to get this part wrong. And if you get writing it wrong, you're going to get the molar mass wrong as well, and that's going to make everything go off. Anyway, we want to know the number of grams. So moles are what we have, grams are what we want. Equals, brackets. We're going to get rid of moles, so they go on the bottom. We're going to get grams, so they go on the top, and there's going to be 1 mole. We always are dealing with 1 mole in this conversion thing, and then the question is just how many grams are there? All right, well, we have to calculate this because it's not something we just read off the table, we read off the pieces. So I grab my periodic table and I start doing some math. Let's use a different color. We've had nothing but black up here on the board. Let's get some blue. For this purpose here, carbon, of course, we know that one is going to be the molar mass of CCl4. So carbon, there's 1 carbon times 12.01 equals 12.01. That one's easy. 4 times 35.45 equals, ooh, don't have that one in my head, thankfully, calculator. 4 times 35.45 equals 141.8. Chlorine's pretty heavy, what can I say? So now in order to get the molar mass, I add these two up, plus 12.01 equals 153.81 grams per 1 mole. I then put this number up here, 153.81. Awesome. So now I have my molar mass. At this point, the conversion becomes easy-ish. Because there's that times 10 to the negative 5, and everyone's calculator is a little different. Went and grabbed some props. So if you've got yourself a TI-84, 83, right, so we'll turn this one on, we're still going to be typing in the basic same idea, right? It's still this multiplied by that. So that part's going to be easy. The question is, how do you do it? So in the case of a TI-83, it's going to be 1.2, and at this point, most students want to hit the multiply sign. That's not going to help you. What you want to do is you want to hit the second function double E key. So it's this one right here on this calculator, right above the 7. It might be in a slightly different place. You want to get the E, which will look like a literal E on your screen, because that E stands for times 10 to the power of. So it like does all of it for you, and then you just type in negative 5. So it'll look something like that. Then I just go times the 153.81 that I want to normally do. The reason you want to do it this way rather than the times 10 and then try to put in the power of is because if you do it that way, you got to put brackets, otherwise it's going to mess everything up. So I hit it there, and I'm going to get a final answer of 0.0018 grams of carbon tetrachloride. Okay, that's how this calculator works. What about another calculator? Here's a Casio calculator. You might have one of those. So we're going to turn it on again. We should get the same answer in the end. So that's how we know we're doing it right. So it's still going to be 1.2. So that part is still the same. But for this calculator, the button you want to hit is this one here that says EXP. It's right down here next to the decimal button. So I hit EXP, and you'll notice it gives that same little E symbol. So EXP to the -5. Then I times all of that by 153.81, and I get exactly the same answer. Yay, we're doing it right so far. All right. If you've got this version of Casio, you'll see that it's almost the same, except that the button is now says times 10 to the x, which again is what the E means, or exponent. That's what the EXP means on this one, is exponent. So it's the same basic idea. Turn the calculator on. It's 1.2. Put 2 decimals times 10 to the power of 5 -5 times 153.81 equals, and there it is. Now this time they wrote it in scientific notation, times 10 to the -3. Now remember, the exponent above the 10, if it was just +3, that means that I would do this, right? I would go 1.845, and I would go 1, 2, 3, making it so the answer was this if it was times 10 to the +3. But that's not what I have. I have 1.845 times 10 to the -3. So if positive makes the decimal move right, negative makes the decimal move left. So I end up getting 1, 2, 3. So I get 0.00185, which is what I got for these guys. I know, it's kind of weird. Now, let me do the last calculator, and then I'll show you. There's actually a trick to all of these scientific notations that might help you. Might. Lastly, this is a Texas TI-30XA. Some of you guys usually have one of these. Here, the button is literally a double E button right there. So once again, I would hit 1.2, double E, and then I would hit my 5-. There it is. Oh, can I get it in frame? There you go. You can see it there. And then once again, I would go times 153.81 equals same answer. All right, so there we go. 4 different calculators. Now, if you're trying to use your cell phone as a calculator, you're going to have to try and find the exponent button. Everyone's cell phone is a little different. I don't recommend it. Trying to use a cell phone for a calculator for this kind of stuff, it's generally not designed for it. You're generally going to have to turn it into probably like rotation mode, so you'll have to set your phone so that when you turn it this way, it will give you a broader, a scientific calculator, but even then, I really don't recommend it. It doesn't work well. So there we go. You guys now have the ability to do the practice that you're going to see on page 8. That's going to be about turning moles into grams. However, anyone who can take a look at page 9 will see that we're going to ask about going from grams to moles. And this shouldn't really be that much of a surprise. I told you at the beginning of the video that we don't have a device that I can just point at things and it tells me how many moles there are. So how could I have a mole number to convert in the first place if I didn't mass it out first on a scale? So the plus side is mass to moles is actually really simple. It's pretty much exactly the same as everything we've already done. We're just going to flip things around. Let's take a look. Page 9 has the example. You do page 8, make sure you get some practice in, but let's take a look at page 9. The example is 24 grams of gold. Gold's coming up again. Isn't that convenient? We'll do it in blue. So 24 grams of gold. Well, this is my conversion formula. It still holds true. I want. What do I want? I want moles of gold. I put my brackets, I put equals. Now at the bottom here, remember, what do I want to get rid of? What do I want to lose? Well, I have grams. I don't want that. I want moles. So I'm going to put grams on the bottom and moles on the top because I want moles. That's what I want to gain, hence the formula. Well, the numbers that go here are the same numbers as here. It's just that the 1 is now on top and the 196.97 is on the bottom. That's it. When it comes to solving this, I don't have to do anything fancy. I'm using all the same numbers. The difference is I have now got to flip it around. Now, under normal circumstances, what would happen is students would try to memorize, to go from moles to grams, I do it this way. To go from grams to moles, I do it that way. You don't need to. you've got a conversion system. You have, you want. You lose, you gain. That's it. That's what you're going for. So 24 times 1, because that's the first thing. So 24 times 1 is just 24. Then divided by 196.97 equals 0.12. So I have 0.12 moles of gold. That's it. We're done. It's the same technique. We just had to flip two numbers. And we didn't have to memorize flipping two numbers. We just have to remember have, want, lose, gain. Okay? Okay, let's try one more. There's one more example here. We have 81 grams of water. All right, well, 81 grams of water. 81, yeah, I about said 84. All right, let's make some space here. We've got grams of water. So on this side, I have 81 grams of H2O. I want moles of H2O. Equals, brackets, brackets, equals. I want to get rid of grams. I want to get moles, right? Because grams, want to get rid of them. Moles, want to get more of them. 1 mole is how many grams for water? Oxygen is 16. Hydrogen is 1. There are 2 oxygens. So yeah, it's 18.02. All right. Now we just got to plug it in. Now, I mean, if you can do that mental math in your head, go right ahead. But I'm going to use a calculator. I mean, I went and got a bunch of them. So O2 equals. I hit the wrong button. 81. See, this is why it's good to write your math on the board, because then you can double check it. Times 1 divided by 18.02 equals 4.5 if I round it up. 4.5 moles. And that's it. That's all you guys have to do. When it comes to converting between grams and moles, there is a single formula, and this one formula will work for all the conversions. There are a lot of conversions in this unit. It will work for all of them. You just have to know what numbers to put in, but you already saw how to find those numbers. So that's it. That's all you guys have to do. And at this point, you guys have the ability to do all the practice up on page 10 and 11. You're not quite ready for page 12 yet, so I'm going to leave it there. See you guys next time.